Now we call these isotopes of carbon. There is an isotope of carbon that has 6 neutrons and a relative mass of 12, and there's an isotope of carbon that has a relative mass of 13 because it has 7 neutrons. So different isotopes of the same element will have the same number of protons, so they've got the same atomic number. This identifies the element, but different numbers of neutrons. Here we've got isotopes of hydrogen. This isotope of hydrogen has an atomic number of 1, that's what makes it hydrogen, but it has a relative mass of 2. So that means it's got 1 proton, 1 neutron. This one has 1 proton, that's what makes it hydrogen, but the total mass, the relative mass is 3, so therefore it must have 2 neutrons to make the total mass up to 3. Here we have an isotope of chlorine. Chlorine has an atomic number of 17, it has 17 protons, which also means it would have 17 electrons in a neutral atom. But it has 18 neutrons, so overall its mass is 35. On the other hand, there's another isotope of chlorine that has a mass of 37. So how many neutrons has it got? It must have 20. When we add the 17 to the 20, we get the total mass of 37. So a definition that you have to learn is isotopes are atoms with the same number of protons but a different number of neutrons. The relative atomic mass takes into account all of these isotopes. So carbon, although we've said that it has isotopes with a mass of 12 and of 13, but actually the majority of carbons have a relative mass of 12. So if we took an average mass of carbon, it has a relative mass of 12. Chlorine, on the other hand, we've looked at it in a previous slide and seen that there's one isotope with 18 neutrons and one isotope with 20 neutrons. So one of them has a mass of 35 and one isotope has a mass of 37. In the periodic table it's given it a relative mass of 35.5. So can you see, does that mean there are more of this isotope here or this isotope here, do you think? Well, it means that the majority of chlorine isotopes are chlorine 35. In fact, 75% of chlorine atoms are chlorine 35 isotopes. Isotopes of chlorine with a relative mass of 35. When we take this into account, the 75% 35 and the 25% 37, it gives us a relative atomic mass. So an atomic mass, the weighted mass of mean mass of chlorine of 35.5. Well, that means that when they take into account all the different isotopes of magnesium, overall it comes out at about 24 as an average atomic mass. Whereas copper, obviously we've got some different isotopes of copper here because when they take a weighted average of all those different isotopes, we get an average of 63.5. So the only other thing you need to know is that all of this, when we talk about a relative mass, obviously we can't get atoms and just weigh them on a scale. Atoms are tiny. Their mass is so tiny that it wouldn't show up on a conventional scale. We can't weigh an individual atom, but we can see how much they weigh in relation to each other. The definition of relative atomic mass, we're looking at the mass of atoms compared to an atom of carbon-12. So a carbon atom with a mass of 12, so 6 protons, 6 neutrons, we use that as our yardstick and compare everything else to it. Beryllium here, we know it must have 4 protons. How many neutrons? Well, it must be 5 because the protons plus the neutrons gives us our overall mass. This is an element that you won't have come across yet, osmium. You can know just from the information you have here that it has 76 protons in it, and even though it's a much larger number, you can still calculate the number of neutrons. How many?